Before we begin this journey, take a moment to imagine the world beneath your feet. Not the cities, not the forests, not the mountains we know so well, but the vast silent realm that covers most of our planet. A world so deep, so dark, and so unexplored that it feels closer to outer space than to anything on land. The ocean is not just a body of water. It is Earth's greatest mystery, a frontier that has shaped life for billions of years while remaining hidden from human eyes. For centuries, we believed we understood our planet. We mapped continents, climbed peaks, and crossed deserts. But the ocean resisted us. It kept its secrets behind pressure, darkness, and distance. Even today, with all our technology, we have explored only a tiny fraction of its depths. The rest remains untouched, a world of strange creatures, ancient landscapes, and forces that shape the entire planet without ever breaking the surface. In this series, we descend into that unknown. We travel into the trenches where mountains taller than Everest rise from the darkness. We witness creatures that glow like living stars, animals that survive under pressures that would crush steel, and ecosystems that thrive without a single ray of sunlight. We follow the nightly migration of trillions of organisms, the largest movement of life on Earth. We meet the immortal jellyfish, the giant blue whale, and the hidden rivers that flow beneath the sea. This is not just a story about the ocean. It is a story about mystery, resilience, and the limits of what we think life can be. It is a reminder that our planet is still wild, still full of wonders, still capable of surprising us. And as we explore these 10 extraordinary facts, we begin to see the ocean not as a distant, silent world, but as a living universe that pulses beneath every wave. So settle in, open your mind, and let the deep speak. The journey into the underwater world begins now. Part 1. The Unexplored Ocean. The ocean begins where certainty ends. For as long as humanity has existed, we have walked the continents, crossed deserts, climbed mountains, and mapped the sky with growing confidence. Yet beneath the surface of the sea lies a world more mysterious than distant planets. More than 80% of Earth's oceans remain unexplored, unmeasured, and unseen. It is not a remote corner of the world. It is the world itself. A vast shifting frontier that surrounds every continent and shapes every climate, yet hides its secrets behind a veil of depth and darkness. The surface of the ocean is a fragile boundary. Above it stretches the familiar realm of sunlight, air, and weather. Below it begins a descent into a universe governed by pressure, cold, and silence. The first few dozen meters are still touched by the sun, a shimmering blue cathedral where life moves in bright, fluid patterns. But as you sink deeper, the light fades, colors dissolve. The water grows colder at 200 meters. Daylight disappears. At 1,000, the world becomes night. And beyond that point, the ocean transforms into something almost alien. Scientists call this immense region the deep ocean, but the name barely captures its scale. It is the largest living space on Earth, a realm so vast that every mountain range on land has an underwater counterpart, every canyon has a deeper twin, and every desert has a drifting mirror made of sand and silt. Entire ecosystems thrive there without sunlight, powered by chemical reactions and ancient heat rising from the planet's crust. Creatures glow with their own light, communicate through pulses and flashes, and navigate a world where pressure can crush steel. Yet they move with effortless grace, as if the abyss were the most natural place to exist. What makes the unexplored ocean so compelling is not only its size, but its silence. Satellites can map the surface of Mars with astonishing precision, yet they cannot see through seawater. Sonar reveals only rough outlines. Submersibles reach only a fraction of the depths. Most of the ocean floor has never been photographed. In many regions, we do not know what species live there, what geological structures rise from the darkness, or how life has adapted to conditions that defy imagination. Every expedition into the deep returns with discoveries, new organisms, new behaviors, new forms of survival. The ocean is not empty, it is overflowing with secrets. The unexplored ocean also holds the memory of Earth's past. Beneath layers of sediment lie the remains of ancient climates, vanished species, and forgotten catastrophes. The ocean floor records the story of the planet more faithfully than any library. It preserves the traces of shifting continents, erupting volcanoes, and meteor impacts that reshaped life. To explore the deep is to read the biography of Earth written in darkness. And yet, despite its importance, the ocean remains largely untouched by human presence, not because it is far away, but because it is difficult. Pressure increases by 1 atmosphere every 10 meters. At 1,000 meters, the force is enough to crush a submarine. At 10,000, it becomes almost unimaginable. Temperatures drop near freezing. Light disappears completely. Communication becomes nearly impossible. Technology struggles to survive. The ocean is not hostile by intention. It is simply indifferent, shaped by physics older than life itself. But this frontier is not just a scientific challenge, it is a philosophical one. The unexplored ocean reminds us that our planet is still wild, still mysterious, still capable of humbling us. In an age where information feels limitless and every corner of the world seems mapped, the ocean stands as a reminder that discovery is far from over. There are mountains taller than the Himalayas, hidden beneath the waves. There are trenches deeper than any valley on land. There are creatures whose forms defy classification, whose existence challenges our understanding of biology. To explore the ocean is to confront the unknown. It is to descend into a world where light has never existed, where life has evolved along paths we can barely imagine, where the boundaries of possibility stretch far beyond our expectations. The unexplored ocean is not just a place, it is a symbol of everything we have yet to learn, a reminder that the greatest mysteries are not always in the stars above us, but in the depths below, and so the story begins here, at the edge of the known world, where the sea becomes a doorway into the vast, uncharted darkness. The unexplored ocean waits, silent and immense, holding secrets that may reshape our understanding of life, Earth, and the universe itself. Part 2. The Mariana Trench. The Mariana Trench is a place where the planet reveals its most extreme geometry. It lies in the western Pacific Ocean, a narrow scar stretching for more than 2,000 kilometers, carved into the Earth's crust by the slow, relentless movement of tectonic plates. At its deepest point, the Challenger Deep, the ocean plunges nearly 11,000 meters into darkness. If you placed Mount Everest at the bottom of this abyss, its peak would still be more than a mile underwater. The trench is not simply deep. It is a reminder that Earth still holds places beyond the reach of ordinary imagination. To descend into the Mariana Trench is to leave behind the world we know. The journey begins in the sunlit shallows, where life is familiar and color still exists. But as the submersible sinks, the light fades, blue becomes black, the water grows colder, heavier, more silent. Pressure increases with every meter, building like an invisible weight. At 1,000 meters, the force is enough to crush a human body instantly. At 6,000, the pressure is comparable to having the weight of 50 jumbo jets, pressing on every square meter. And yet the descent continues, deeper and deeper, into a realm where the rules of life seem rewritten. The trench is shaped by subduction, the process in which one tectonic plate slides beneath another and sinks into the mantle. This slow collision bends the ocean floor downward, creating a chasm deeper than any valley on land. The walls of the trench rise like underwater cliffs, jagged and steep, sculpted by landslides and earthquakes. The floor is covered in fine sediment, a soft shifting layer of dust that has drifted down for millions of years. It is a graveyard of particles, a record of ancient oceans, volcanic eruptions, and the slow decay of life at the surface. Despite the crushing pressure and eternal darkness, life exists here, not in abundance but in resilience. Amphipods, small crustaceans with translucent bodies, swim through the black water. Certain species of snailfish thrive at depths once thought impossible for vertebrates. Microbes live within the sediment, feeding on chemical energy rather than sunlight. These organisms are adapted to a world where bones would shatter and lungs would collapse, yet they move with quiet purpose, as if the abyss were a sanctuary rather than a prison. Exploring the Mariana Trench is a technological challenge unlike any other. Only a handful of crewed missions have ever reached the bottom. Most of what we know comes from robotic landers and autonomous vehicles built to withstand pressures that would crush steel. Even these machines struggle. Electronics fail. Hulls deform. Communication becomes a whisper through thousands of meters of water. The trench is not hostile by intent. It is simply governed by physics that do not care whether we survive. And yet every expedition reveals something new. strange creatures with gelatinous bodies, microbes that metabolize minerals in ways never seen before. Geological formations shaped by forces deep within the earth. The trench is not empty. It is alive with quiet complexity. It is a laboratory of evolution, a place where life has adapted to extremes that challenge our understanding of biology. The Mariana Trench also holds clues to Earth's history. Sediment cores reveal ancient climates, shifting ocean currents, and the long arc of geological time. The trench floor records the slow dance of tectonic plates, the rise and fall of continents, and the deep processes that shape the planet. To study the trench is to study Earth itself, not as a static world, but as a living, changing system. But perhaps the most profound aspect of the Mariana Trench is what it represents. In an age where satellites map the globe and information seems limitless, the trench remains a frontier untouched by certainty. It reminds us that the world is still vast, still mysterious, still capable of humbling us. The deepest point on Earth is not a place of death, but a place of possibility. A reminder that exploration is far from over, and that the greatest mysteries may lie not in the stars above, but in the darkness below. The Mariana Trench is a monument to the unknown, a silent, immense world that challenges our assumptions about life, pressure, and the limits of the human spirit. It waits in the depths, unchanged by time, holding secrets that may reshape our understanding of what it means to live on this planet. And as long as curiosity drives us forward, the trench will remain a destination for those who seek to understand the hidden architecture of Earth. Part 3. Life under crushing pressure. There is a moment, somewhere far below the reach of sunlight, when the ocean stops feeling like water and begins to feel like weight. Every 10 meters adds another atmosphere of pressure. At 1,000 meters, the force is enough to collapse a human body in an instant. At 6,000, it becomes a silent, invisible mountain pressing from all directions. And yet, in this world of crushing force, life not only survives, it thrives. To understand life under extreme pressure, you must imagine a world where the rules of biology bend. Bones would shatter, lungs would implode, air-filled spaces would collapse like paper. But the creatures of the deep have no such weaknesses. Their bodies are soft, flexible, gelatinous. They are shaped not to resist pressure but to exist in harmony with it. In the abyss, strength is not measured by hardness but by adaptability. The descent into this realm begins with a slow fading of color. Red disappears first, swallowed by the water, then orange, yellow, green. At a few hundred meters, only blue remains. At 1,000, even blue dissolves into darkness. The world becomes a place without shadows, without horizons, without any reference to the surface above. It is a world defined by pressure, cold, and silence. Here, the temperature hovers just above freezing. The water is thick with microscopic snow, organic particles drifting downward from the world above. This constant rain of life, called marine snow, is the primary source of food for many deep-sea creatures. It is a slow, patient economy, where survival depends on efficiency rather than speed. Every movement is measured. Every calorie is precious. The animals that live here are unlike anything found in the sunlit world. Some have bodies so delicate they would collapse under their own weight if brought to the surface. Others have evolved chemical structures that prevent their proteins from deforming under pressure. Their eyes are enormous, adapted to capture the faintest glimmer of bioluminescent light. Their mouths are wide, their stomachs expandable, because meals are rare and unpredictable. In the deep, opportunity must never be wasted. One of the most remarkable inhabitants of this realm is the deep-sea snailfish. It thrives at depths once thought impossible for vertebrates. Its body is soft and translucent, its bones reduced to flexible cartilage. It moves with slow, graceful motions, as if the crushing pressure were nothing more than a gentle embrace. The snailfish is a reminder that life does not merely endure the abyss. It belongs to it. Other creatures rely on bioluminescence, producing their own light through chemical reactions. In the darkness, these flashes become a language. Some use light to attract prey. Others use it to confuse predators. Some communicate with patterns of glowing pulses, sending signals across the black water. The deep ocean is not silent. It is alive with flickers and whispers of light, a galaxy of living stars drifting through the dark. Pressure shapes not only the bodies of deep-sea creatures, but their behavior. Many move slowly to conserve energy. Some drift with the currents, letting the ocean carry them. Others wait motionless for prey to come close. In a world where food is scarce and movement is costly, patience becomes a survival strategy. Exploring this realm is one of the greatest challenges in modern science. Submersibles must be built with titanium hulls capable of withstanding forces that would crush steel. Electronics must be protected from deformation. Cameras must operate in near-total darkness. Every descent is a test of engineering, a negotiation with the physics of the deep. And yet, each mission reveals new species, new behaviors, new adaptations. The abyss is not empty. It is a frontier of life. Life under crushing pressure forces us to rethink what is possible. It shows that biology is not fragile, but endlessly inventive. It reveals that life can flourish in conditions that seem hostile beyond imagination. And it reminds us that the boundaries of the living world are far wider than the narrow band of sunlight where humans evolved. In the end, the deep ocean is a testament to resilience. It is a world shaped by pressure yet filled with life that moves with quiet confidence. A world where darkness becomes a canvas for light. A world where survival is an art refined over millions of years. Life under crushing pressure is not a story of suffering. It is a story of adaptation, endurance, and the extraordinary creativity of evolution. And as we continue to explore this realm, we discover not only new species, but new ways of understanding life itself. The deep ocean teaches us that existence is not limited by comfort, light, or warmth. It is limited only by imagination. And in the crushing darkness of the abyss, imagination has created forms of life more strange and beautiful than anything found on land. Part 4. The Ocean of Light. In the deep ocean, where sunlight never reaches and darkness has ruled for millions of years, life has discovered a way to create its own illumination. It is a world where light is not borrowed from the sun but forged within living bodies. A world where creatures glow in blues, greens, and ghostly whites, turning the abyss into a silent galaxy of drifting stars. This phenomenon is called bioluminescence, and it is one of the most extraordinary adaptations on Earth. To understand the ocean of light, you must first imagine the darkness. At a few hundred meters below the surface, the last traces of sunlight fade. At 1,000 meters, the world becomes a black void. There are no shadows, no horizons, no reflections. It is a darkness so complete that even the concept of night loses meaning. And yet, in this eternal night, light appears, not from above, but from within. Bioluminescence is a chemical reaction, a precise dance between molecules that releases energy as light. It is efficient, cold, and controlled. Unlike fire, it produces no heat. Unlike electricity, it requires no wires. It is life's own lantern, evolved again and again across countless species. In the deep ocean, more than 3/4 of all animals can produce light. It is not a rare trick. It is the language of the abyss. Some creatures use light to hunt. The anglerfish, drifting motionless in the dark, dangles a glowing lure from its forehead. Small fish, drawn to the faint shimmer, approach with curiosity. In an instant, the anglerfish strikes, swallowing its prey whole. Other predators use bioluminescence to illuminate the water around them, revealing the silhouettes of potential meals. In a world where vision is limited, even a faint glow can mean survival. But light is not only a weapon, it is also a shield. Many deep-sea animals use bioluminescence to confuse predators. When threatened, they release clouds of glowing particles, creating a shimmering distraction while they escape into the darkness. Some species produce flashes that mimic the patterns of other creatures, tricking predators into chasing illusions. Others use counterillumination, glowing on their undersides to match the faint light from above, making their bodies nearly invisible from below. In the deep ocean, light becomes camouflage. Communication is another purpose. Certain species of squid send pulses of light across their bodies, signaling to others of their kind. Some fish use rhythmic flashes to attract mates, each species with its own unique pattern. In the darkness, these signals become conversations, silent but unmistakable. The ocean of light is not chaotic. It is structured, intentional, and full of meaning. Perhaps the most mesmerizing displays come from the tiny organisms that drift through the water in vast numbers. When disturbed, they ignite in waves of blue light, creating glowing trails behind swimming animals or shimmering clouds around passing currents. In some regions, entire underwater landscapes appear to sparkle as if the stars themselves have fallen into the sea. These microscopic lights are the heartbeat of the deep, a constant reminder that even the smallest forms of life can shape the beauty of the world. Exploring this realm is a challenge. Cameras struggle to capture the faint glow without overwhelming it. Submersibles must move slowly to avoid disturbing the delicate displays. Scientists often describe the experience as witnessing a living night sky, where each flash is a story, each glow a signal, each pulse a survival strategy refined over millions of years. The ocean of light is not a spectacle created for us. It is a system of communication, hunting, and defense that has evolved in perfect harmony with the darkness. Bioluminescence also reveals something profound about life on Earth. It shows that evolution is not limited by the absence of sunlight. It demonstrates that life can create its own solutions to the challenges of its environment. In the deep ocean, where pressure crushes, cold numbs, and darkness dominates, life has invented a new kind of illumination, a light that belongs to the creatures themselves, not to the sky above. The ocean of light is a reminder that beauty exists even in the most extreme places. It is a testament to the creativity of evolution, a celebration of life's ability to adapt, survive, and communicate in ways that defy expectation. In the darkness of the abyss, light becomes more than a tool. It becomes a symbol of resilience, a quiet declaration that life will find a way even in the deepest shadows. And so the deep ocean glows, not with the warmth of the sun, but with the cold fire of living stars. A world where darkness is never absolute, where every flicker carries meaning, and where the boundaries of possibility stretch far beyond the limits of the surface world. Part 5. Earth's Nightly Migration. Every night, while the surface world sleeps, the ocean awakens with the largest movement of life on the planet. It is a migration so vast, so ancient, and so consistent that it happens every single evening without fail. Trillions of organisms rise from the deep, traveling upward through the dark water in a silent procession that spans the entire globe. This phenomenon is known as the Deal vertical migration, and it is the greatest daily journey undertaken by any living community on Earth. To understand this migration, you must imagine the ocean as a layered world. The surface is bright, warm, and full of predators. The deep is cold, dark, and safer, but poor in food. For countless species, survival depends on moving between these two realms. As the sun sets and the last rays of light fade from the water, tiny organisms begin their ascent. Zooplankton, shrimp, squid, jellyfish, and countless other creatures rise toward the surface to feed on the rich layer of microscopic life that thrives in the sunlit zone. They move slowly, carefully, guided by instincts older than humanity itself. The scale of this migration is almost impossible to grasp. It is not limited to one region or one species. It happens everywhere, in every ocean, from the tropics to the poles. It is a synchronized movement of life that spans thousands of kilometers horizontally and hundreds of meters vertically. If you could drain the oceans and watch the migration from above, it would look like a living tide rising from the abyss, a wave of motion sweeping upward across the entire planet. The creatures that participate in this nightly journey are diverse. Some are no larger than grains of sand, others are the size of a human hand. Many are transparent, their bodies shaped by the need to remain invisible in the dim light. Some glow with bioluminescence, leaving faint trails of blue as they move. Others rely on delicate fins or rhythmic pulses to propel themselves upward. Each species has its own rhythm, its own strategy, its own place in the vast choreography of the migration. The purpose of this journey is simple: survival. During the day, the surface waters are dangerous. Predators with sharp eyes patrol the bright shallows, hunting anything that moves. By staying deep during daylight hours, small organisms avoid detection. But the deep ocean is poor in nutrients. To feed, they must rise to the surface at night when darkness provides cover. It is a delicate balance between hunger and safety, a daily negotiation with the physics of light and the instincts of predators. As the migrating creatures reach the surface, they begin to feed. Zooplankton graze on phytoplankton, the microscopic plants that form the foundation of the ocean's food web. Small fish feed on the zooplankton. larger predators follow. The surface becomes a temporary feeding ground, a brief window of opportunity before dawn forces the entire community to retreat. When the first hints of morning light appear, the migration reverses. The creatures sink back into the depths, disappearing into the darkness before the sun can expose them. This nightly movement has profound effects on the planet. It transports nutrients from the surface to the deep ocean, helping to regulate global carbon cycles. It influences the behavior of predators, the distribution of species, and the flow of energy through marine ecosystems. It is a hidden engine of the ocean, a force that shapes life on Earth in ways we are only beginning to understand. For scientists, studying this migration is a challenge. The creatures involved are small, fragile, and easily disturbed. Their movements are influenced by moonlight, temperature, currents, and countless other factors. Submersibles and sensors reveal glimpses of the migration, but much of it remains mysterious. It is a phenomenon too large, too complex, and too ancient to fully capture, yet every discovery reveals new layers of meaning. The migration is not just a biological event, it is a planetary rhythm. Perhaps the most remarkable aspect of Earth's nightly migration is its consistency. It has been happening for millions of years, long before humans existed. It will continue long after we are gone. It is a reminder that the ocean is alive with patterns and cycles that operate independently of our awareness. While we sleep, the ocean moves. While we dream, life rises and falls in a silent procession that spans the globe. In the end, the nightly migration is a testament to the interconnectedness of life. It shows that even the smallest creatures can shape the world in profound ways. It reveals that survival is not always about strength or speed, but about timing, adaptation, and the ability to move with the rhythms of the planet. And it reminds us that beneath the surface of the sea, there is a world of motion, mystery, and beauty that continues whether we witness it or not. Earth's nightly migration is the heartbeat of the ocean, a pulse that rises with the darkness and sinks with the dawn. A silent journey that connects the deep with the surface, the past with the present, and the smallest forms of life with the vast machinery of the planet. Part 6. The Immortal Jellyfish. In the vastness of the ocean, where life has evolved into shapes both familiar and alien, there exists a creature that challenges one of the deepest assumptions we hold about biology. It is small, delicate, and almost invisible to the naked eye, and yet it possesses an ability so extraordinary that scientists once believed it impossible. This creature is Turritopsis dohrnii, better known as the immortal jellyfish. It is the only known animal capable of reversing its own aging process and returning to an earlier stage of life, effectively resetting its biological clock. To understand the significance of this ability, you must imagine the life cycle of a typical jellyfish. It begins as a tiny larva, settles on a surface, and transforms into a polyp. The polyp then produces free-swimming medusae, the familiar bell-shaped form that drifts through the water. Eventually, the medusa ages, weakens, and dies, but Turritopsis dohrnii breaks this pattern. When injured, stressed, or threatened by starvation, it does something unprecedented. Instead of dying, it transforms its adult cells back into their earliest form, reverting to a polyp and beginning life again. This process is called transdifferentiation, and it is one of the most remarkable feats in the natural world. Cells that once had specialized roles, muscle cells, nerve cells, reproductive cells, are reprogrammed into entirely different types. It is as if a butterfly, facing danger, could turn itself back into a caterpillar. No other animal has been observed performing such a complete reversal. The immortal jellyfish does not merely heal, it rewinds. The creature itself is tiny, no larger than a fingernail. Its bell is transparent, its tentacles delicate. It drifts through warm and temperate oceans, carried by currents, unnoticed by most marine life. Yet its impact on science is enormous. Researchers study it not because it threatens ecosystems or dominates food webs, but because it reveals something profound about the nature of aging. If a creature can reverse its own decline, what does that mean for the limits of life? Despite its nickname, the immortal jellyfish is not invincible. It can still be eaten by predators. It can still fall victim to disease. But biologically, it has no fixed lifespan. It does not age in the way humans do. It does not accumulate irreversible damage. It does not march toward death with each passing year. Instead, it cycles between youth and maturity, a loop that may continue indefinitely as long as external threats do not intervene. The discovery of this ability has reshaped scientific discussions about regeneration. Many animals can regrow parts of their bodies. Starfish can regenerate arms. Salamanders can regrow limbs. But the immortal jellyfish goes further. It regenerates itself entirely. It is not repairing damage. It is rebuilding identity. This raises questions that reach beyond marine biology. How flexible are the rules of life? How far can evolution push the boundaries of what a cell can become? Studying the immortal jellyfish is difficult. Its small size makes it challenging to track in the wild. In captivity, it requires precise conditions to trigger its transformation. Scientists have observed the process in laboratories, watching as the medusa collapses into a cyst-like form and then re-emerges as a polyp. Each time, the cycle begins anew. It is a biological reset button, pressed by stress, injury, or environmental change. The implications extend into fields like aging research, regenerative medicine, and cellular biology. If nature has found a way to reverse cellular specialization, perhaps similar mechanisms exist in other organisms, hidden or dormant. The immortal jellyfish does not offer a blueprint for eternal life, but it does reveal that aging is not as rigid or inevitable as once believed. It shows that evolution can produce solutions that defy expectation, even in creatures as simple as jellyfish. Yet beyond the science, there is something poetic about this tiny animal drifting through the ocean, quietly rewriting the rules of existence. It reminds us that the sea is full of mysteries, many of them small, delicate, and easily overlooked. It shows that profound discoveries do not always come from the largest creatures or the deepest trenches, but from the unnoticed corners of the natural world. The immortal jellyfish is a symbol of resilience, adaptation, and the boundless creativity of evolution. It is a reminder that life is not a straight line from birth to death, but a spectrum of possibilities shaped by environment, pressure, and time. In the endless darkness of the ocean, this tiny creature carries a secret that challenges our understanding of what it means to live, to age, and to begin again. And so it drifts, fragile yet extraordinary, a quiet testament to the idea that nature still holds answers to questions we have not yet learned to ask. Part 7. The blue whale. In the history of life on Earth, no creature has ever matched the size of the blue whale. Not the towering sauropods of the Jurassic, not the armored giants of the Cretaceous. Nothing that has walked, crawled, or flown has ever reached the scale of this living titan. The blue whale is the largest animal known to have existed, a creature so immense that its presence reshapes the water around it, a moving mountain drifting through the sea. To understand the blue whale, you must first understand the ocean that created it. The sea is the only environment capable of supporting such size. Water lifts what gravity would crush. It allows mass to grow without the burden of supporting its own weight. In this buoyant world, evolution pushed the boundaries of scale until it produced a creature longer than a basketball court and heavier than a fully loaded commercial airplane. An adult blue whale can reach 30 meters in length and weigh more than 180 tons. Its heart alone is the size of a small car. Its arteries are so wide that a child could crawl through them. Yet despite its size, the blue whale feeds on some of the smallest animals in the ocean. Its diet consists almost entirely of krill, tiny shrimp-like creatures that gather in dense swarms. During feeding season, a single whale can consume more than 3 tons of krill in a day. It does this through lunge feeding, accelerating toward a cloud of prey and opening its enormous mouth to engulf water, krill, and everything in between. Its throat expands like a parachute, stretching to hold volumes of water larger than its own body. Then the whale closes its mouth and forces the water out through baleen plates, trapping the krill inside. It is a feeding strategy that requires immense energy, yet it fuels the largest body ever known. The blue whale's voice is another marvel. It produces some of the lowest frequency sounds in the animal kingdom, calls so deep that they can travel across entire ocean basins. These vocalizations are not heard by human ears but felt as vibrations. Scientists believe whales use them to communicate across vast distances, navigating the open ocean with a language shaped by pressure and depth. In the darkness of the deep, sound becomes a map. Despite their size, blue whales are gentle. They move with slow, deliberate grace, their massive bodies gliding through the water with almost no effort. Their flukes rise and fall in a steady rhythm, each movement sending ripples through the sea. They are not predators in the traditional sense. They do not chase, strike, or tear. They filter. They drift. They exist in harmony with the smallest life around them. But their size does not protect them from danger. In the 20th century, industrial whaling brought blue whales to the brink of extinction. Faster ships, explosive harpoons, and global demand for whale oil led to the deaths of hundreds of thousands of individuals. By the time commercial whaling was banned, blue whale populations had collapsed by more than 90%. The largest animal ever to live was nearly erased in a single human lifetime. Today, blue whales are protected and their numbers are slowly recovering, but they still face threats. Ship strikes, noise pollution, entanglement in fishing gear, and the shifting patterns of krill caused by climate change all affect their survival. The ocean is changing, and the blue whale must adapt to a world transformed by human activity, yet their resilience is remarkable. They continue to migrate across thousands of kilometers each year, following ancient routes from feeding grounds to breeding waters. They continue to sing, to feed, to raise calves in the vastness of the sea. A newborn blue whale is already one of the largest animals on Earth. At birth, it weighs around 3 tons and measures 7 meters in length. It drinks more than 100 liters of milk per day, growing at a rate unmatched by any other mammal. In its first year, it gains weight faster than any creature known, adding tens of kilograms every day. This rapid growth is necessary, for the ocean is vast and survival demands strength. The blue whale is not just an animal. It is a symbol of what life can become when evolution is given time, space, and freedom. It represents the upper limit of biological possibility, a reminder that the natural world is capable of producing wonders far beyond our expectations. To see a blue whale is to witness the scale of the ocean made flesh. To hear its voice is to feel the heartbeat of the planet. And yet, for all its size, the blue whale remains elusive. It spends most of its life far from shore, traveling through open waters where few humans ever venture. It surfaces briefly, exhales a towering plume of mist, then sinks back into the depths. It is a giant that leaves almost no trace, a titan that moves with the quiet confidence of a creature perfectly adapted to its world. The blue whale is a testament to the power of the ocean, a living monument to the possibilities of life. It reminds us that the sea is not only a place of mystery and danger, but also a cradle of giants. And as long as these creatures continue to glide through the deep, the ocean will remain a place of awe, wonder, and endless discovery. Part 8. Life without sunlight. Far beneath the waves, in a world where sunlight has never existed, life has found a way to flourish. It is a realm of darkness, pressure, and silence, a place where the familiar rules of biology seem to dissolve. And yet, in this hostile environment, entire ecosystems thrive around structures known as hydrothermal vents. These vents, discovered only in 1977, revealed one of the most astonishing truths in modern science. Life does not need sunlight to exist. It can be powered by the Earth itself. Hydrothermal vents form along mid-ocean ridges, where tectonic plates pull apart and magma rises from the mantle. Seawater seeps into cracks in the ocean floor, heats to temperatures exceeding 400 degrees Celsius, and becomes infused with minerals and chemicals. When this superheated water erupts back into the ocean, it forms towering chimneys of black smoke, rich in hydrogen sulfide, methane, and metals. To humans, these chemicals are toxic. To the creatures of the deep, they are the foundation of life. The discovery of these vents overturned a fundamental assumption. For centuries, scientists believed that all life on Earth depended on the sun. Plants captured sunlight, animals ate plants, and the chain continued upward. But at the vents, there is no light, no photosynthesis, no plants. Instead, life is built on chemosynthesis, a process in which bacteria convert chemical energy into organic matter. These bacteria form the base of an entirely separate food web, one that operates independently of the surface world. The animals that live around hydrothermal vents are unlike anything found elsewhere. Giant tube worms, more than 2 meters long, anchor themselves to the chimneys. They have no mouths, no stomachs, and no digestive systems. Instead, they rely on symbiotic bacteria living inside their bodies. The bacteria perform chemosynthesis, producing nutrients that feed the worms. It is a partnership so complete that neither organism could survive without the other. Nearby, massive clams and mussels cluster in dense beds, their tissues also filled with chemosynthetic bacteria. Blind shrimp gather around the hottest parts of the vents, their bodies adapted to sense faint thermal gradients rather than light. Some species of crabs and fish patrol the area, feeding on the smaller organisms that thrive in the mineral-rich water. The entire community is built on chemistry, not sunlight. Temperatures around the vents vary dramatically. The water inside the chimneys can exceed the boiling point many times over. Yet just a few meters away, the surrounding ocean remains near freezing. Life must navigate this extreme gradient, finding the narrow zones where conditions are survivable. Pressure adds another challenge. At depths of 2 to 3 kilometers, the force is hundreds of times greater than at the surface, yet the creatures here move with ease, perfectly adapted to their environment. Hydrothermal vents are not permanent. They can last for decades or centuries, but eventually they collapse or shift as the tectonic plates continue to move. When a vent dies, the ecosystem around it collapses as well. But life is resilient. Larvae drift through the deep ocean, searching for new vents. When they find one, the cycle begins again. Entire communities rise, flourish, and vanish, following the slow heartbeat of the Earth's crust. The existence of life without sunlight has profound implications. It suggests that life may exist in places once considered impossible. Moons like Europa and Enceladus, with their subsurface oceans and geothermal activity, may host ecosystems powered by chemistry rather than light. The vents on Earth are not just biological marvels. They are windows into what life might look like elsewhere in the universe. Studying these ecosystems is difficult. The vents are located in some of the deepest parts of the ocean, accessible only by advanced submersibles and remotely operated vehicles. The extreme temperatures and chemical conditions challenge even the most sophisticated equipment. Yet every expedition reveals new species, new adaptations, and new insights into the flexibility of life. The deep ocean remains one of the least explored environments on Earth, and hydrothermal vents are among its most extraordinary discoveries. Life without sunlight is a reminder that biology is not limited by the conditions we consider normal. It shows that life can emerge wherever energy exists, whether from the sun, from chemicals, or from the heat of the planet itself. It reveals that evolution is not bound to a single path, but capable of producing solutions that defy expectation. In the darkness of the deep ocean, life has found a way to thrive without the warmth of the sun. It has built ecosystems around the Earth's internal heat, transforming toxic chemicals into nourishment. It has created partnerships between bacteria and animals that blur the boundaries of individuality. And it has shown that the story of life is far more diverse, far more inventive, and far more resilient than we ever imagined. The vents glow faintly in the darkness, not with light, but with life, a reminder that even in the most extreme places, the spark of existence can take hold and flourish. Part 9. Rivers beneath the sea. There are places in the ocean where the laws of the surface world seem to bend. Places where water flows through water, where shorelines exist without land, where waves ripple across a landscape hidden beneath hundreds of meters of sea. These are the underwater rivers and lakes of the deep ocean, formed not by fresh water but by dense, mineral-rich brine. They are among the most surreal environments on Earth, places so strange that early explorers described them as otherworldly, as if they had stumbled into a world that should not exist. To understand how a river can flow beneath the sea, you must imagine the chemistry of the deep ocean. In certain regions, salt concentrations become so high that the water turns into brine, far denser than the surrounding seawater. This brine collects in depressions on the seafloor, forming pools that behave like lakes. Their surfaces ripple, their edges form distinct shorelines. Their currents flow along channels carved into the sediment. The boundary between brine and seawater is so sharp that submersibles can float on top of it, just as a boat floats on a lake. One of the most famous examples is the Jacuzzi of Despair, a brine pool in the Gulf of Mexico. Its salinity is so extreme that most animals die instantly upon entering it. Crabs, fish, and other creatures lie preserved along its edges, victims of a chemical trap, yet even here, life persists. Mussels and tube worms cluster around the pool's margins, supported by chemosynthetic bacteria that thrive on methane and hydrogen sulfide seeping from the seafloor. It is a reminder that even in the most hostile environments, life finds a foothold. Other underwater rivers, such as those found in the Black Sea and the Mediterranean, are shaped by underwater topography. Dense water flows along the seafloor like a river through a canyon, complete with meanders, rapids, and even waterfalls. In the Black Sea, researchers have mapped a submerged river system larger than the Thames, complete with tributaries and carved banks. These rivers transport sediment, nutrients, and organic matter across the deep ocean, shaping ecosystems far below the reach of sunlight. The physics behind these rivers is simple, yet the result is astonishing. Dense brine sinks. Lighter seawater rises. When the two meet, they do not mix immediately. Instead, they form a boundary called a halocline, a shimmering interface that looks like heat haze. Submersibles passing through this layer experience a sudden jolt as if breaking the surface of a lake. Cameras blur. Lights refract. The world becomes distorted, as though the ocean itself were bending reality. For the animals that live near these underwater rivers, the environment is both dangerous and rich. The chemical gradients around brine pools support unique communities of life. Bacteria feed on methane and sulfide. Mussels and clams rely on symbiotic microbes. Certain species of shrimp and fish hover near the edges, exploiting the nutrients without crossing into the deadly brine. It is a delicate balance, a dance along the boundary between life and death. Exploring these environments is a challenge. The brine is so dense that remotely operated vehicles can become stuck, unable to descend through the thick layer. Instruments corrode quickly in the chemical soup. Visibility is distorted by the shimmering halocline. Yet scientists continue to return. Drawn by the mystery of these underwater landscapes, each expedition reveals new details, unexpected species, unusual geological formations, and chemical processes that reshape our understanding of the deep ocean. The existence of underwater rivers also has implications beyond Earth. On moons like Titan, where liquid methane flows across the surface, or Europa, where subsurface oceans may interact with mineral-rich rock, similar processes could create environments where life might emerge. The rivers beneath our own oceans serve as analogs for alien worlds, offering clues about how ecosystems might form in places far from the warmth of the sun. But perhaps the most striking aspect of these underwater rivers is their beauty. In the glow of submersible lights, the brine pools shimmer like mercury. Their surfaces ripple gently, disturbed by currents or the movement of nearby animals. The channels carved into the seafloor resemble canyons and valleys, complete with cliffs and overhangs. It is a landscape that feels familiar yet impossibly strange, a reminder that the ocean still holds wonders that defy expectation. Rivers beneath the sea challenge our assumptions about what water can be, how life can adapt, and how landscapes can form in the absence of air and sunlight. They reveal that the ocean is not a uniform mass, but a world of layers, boundaries, and hidden currents. And they remind us that even in the deepest darkness, the Earth continues to shape itself in ways we are only beginning to understand. In these submerged rivers, the ocean becomes a mirror of the surface world, reflecting its patterns while rewriting its rules. A world within a world, flowing silently through the darkness. Part 10. The Unknown Ocean. The ocean covers more than 70% of our planet, yet most of it remains a mystery. More than 90% of marine species are still undiscovered, unclassified, or unseen by human eyes. It is a staggering truth, one that reshapes our understanding of Earth itself. We live on a planet dominated not by land, but by water, and the vast majority of that water is unexplored. The unknown ocean is not a poetic idea, it is a scientific reality. To grasp the scale of this unknown, imagine the deepest trenches, the darkest plains, and the coldest currents. These regions stretch across millions of square kilometers, forming landscapes more expansive than all the continents combined. And yet we have mapped the surface of Mars with greater precision than the seafloor beneath our own oceans. Satellites cannot penetrate seawater. Sonar reveals only rough outlines. Submersibles reach only a fraction of the depths. The ocean hides its secrets behind pressure, darkness, and distance. Every expedition into the deep reveals something new. A fish with transparent skin. A jellyfish shaped like a living chandelier. A worm that builds tubes from minerals. A crustacean that glows like a floating ember. Many of these creatures belong to groups so ancient that they predate the dinosaurs. Others represent entirely new branches of the tree of life. In some cases, scientists discover species that do not fit into any known category, forcing them to rewrite evolutionary relationships. The unknown ocean is not empty. It is overflowing with life that defies expectation. One reason for this vast unknown is the sheer difficulty of exploration. The deep ocean is a world of extremes. Pressure increases by 1 atmosphere every 10 meters. At depths of 6,000 meters, the force is enough to crush steel. Temperatures hover near freezing. Light disappears completely. Communication becomes nearly impossible. Even the most advanced submersibles can only spend limited time at extreme depths. The ocean is not hostile by intention. It is simply governed by physics that challenge our technology. Yet despite these challenges, scientists continue to push deeper. Remotely operated vehicles descend into trenches, capturing footage of creatures that look like they belong on another planet. Autonomous robots glide through the midwater zone, recording the movements of animals that migrate hundreds of meters every night. Deep-sea landers sit on the ocean floor for months, collecting data on currents, chemistry, and life. Each mission expands our understanding, but also reveals how much remains unknown. The unknown ocean also holds clues to Earth's history. Sediment layers preserve records of ancient climates, volcanic eruptions, and meteor impacts. Fossils buried in the deep reveal species that once thrived in warm, shallow seas. Chemical signatures in the water trace the movement of currents that have shaped global weather for millions of years. The ocean is not just a habitat. It is a library of planetary memory. But perhaps the most profound mystery lies in the possibility of life forms unlike anything we have seen. In the deep ocean, evolution follows different rules. Without sunlight, organisms rely on chemical energy. Without stable temperatures, they adapt to extremes. Without predictable food sources, they develop strategies that seem almost alien. Some scientists believe that the deep ocean may contain entire ecosystems that operate independently of the surface world, shaped by pressures and chemistries we barely understand. The unknown ocean also raises questions about the future. As climate change alters temperatures and currents, species may shift, adapt, or disappear. Some deep-sea creatures may hold biochemical secrets that could advance medicine, technology, or energy production. Others may be vulnerable to human activity long before we even discover them. The ocean is both a frontier of possibility and a reservoir of fragility. For all our advances, we have explored only a tiny fraction of the deep. The rest remains untouched, unseen, and unmeasured. It is a reminder that Earth is still a wild planet, still capable of surprising us, still filled with mysteries waiting in the darkness. The unknown ocean is not a void. It is a frontier of life, complexity, and wonder. And so we end this journey where curiosity begins, at the edge of the known world, looking into the vastness below. The ocean remains a place of unanswered questions, a realm where discovery is not the exception but the rule. As long as we continue to explore, the unknown will shrink, but it will never disappear entirely. The sea is too deep, too vast, too ancient. The unknown ocean is a reminder that our planet is far more mysterious than we imagine. A world of secrets hidden beneath the waves, waiting for the moment when light, technology, and human curiosity finally reach them. Thank you for listening to this journey into the deep. For traveling through darkness and pressure, through glowing creatures and ancient mysteries, through worlds that exist far beyond the reach of sunlight. The ocean is a reminder that our planet is still full of secrets, still full of life that challenges our imagination, still full of places where discovery is not a luxury but a certainty. Every trench, every current, every drifting organism tells a story older than humanity itself, and by exploring these stories, we begin to understand not only the ocean, but our own place on this planet. If this series inspired you, if it sparked curiosity or opened a new perspective, consider supporting the channel. A simple like helps more than you might think. A comment helps the algorithm understand that this content matters. And a subscription ensures you never miss the next journey, the next mystery, the next step into the unknown. Your support allows these stories to continue, to grow, to reach others who share the same fascination with the hidden world beneath the waves. So thank you for being here. Thank you for giving your time, your attention, and your curiosity. The ocean is vast, and we have only touched the surface. More stories are waiting, more wonders lie ahead, and together we will keep exploring them one depth at a time.